Hello! Given that it's now the middle of November, I figured it was finally time for another update video. A lot has happened since the last update video, and I would like to update all of you on what's been going on. So the most important thing that's happened since then is the Printalyzer Densitometer is finally available for sale. You can find a link to the store page down below in the description. For now, it is available at a reduced introductory price until the initial production batch sells out. Once that happens, future production batches will be listed at a slightly higher price. I decided to start with this initial batch as a way of getting the whole manufacturing process all figured out and dialed in, and taking notes on places I can improve, and trying not to delay the process by too much. However, I've already started building the next batch, so once this first batch sells out, it won't be too long before the next batch is available. However, I didn't want the first batch to sell out too quickly, so promotions to this point have mostly been limited to notifying email subscribers, the occasional forum post, and a pretty exciting episode of Matt Marrash's Large Format Friday a few days ago, where he showed off this product along with another one. So, why has it taken so long to get this product out the door? Well, I originally planned to start production back in August, and there were a number of delays. Let's just say almost every custom-made piece of the device had some sort of manufacturing issue that I had to work through, be it either quality control or delays or scheduling. A lot of these things just took longer than expected and required more attention than planned. And almost none of those issues happened during any of the pre-production or prototype phases. So this is just something that happens, and I'm hoping it'll happen less in the future, but it was just something that had to be dealt with. Thankfully, at this point, most of those roadblocks have been cleared and things are moving ahead. So, where do we go from here? Well, now that the black and white densitometer is finally out the door, there are some follow-on projects that I need to start working on. Getting those going is going to take a little bit of time, mostly because I'm still busy building black and white Printalyzer Densitometer units, and we're coming up on the winter break season, where availability to work heads down on problems might be a little spotty. The first thing that I'd like to talk about is something that gets asked about from time to time is, people wonder if they can use the Printalyzer Densitometer for color or for measuring alternative process materials. Well, unfortunately, the answer is really no. It's very much designed to measure the portion of the light spectrum used for black and white densitometry, which is typically in the green range. It's specifically what's defined as ISO 5-3 2009 visual, but it's approximately around green. And color needs to also measure red and blue at very specific wavelengths. And alt process people typically want to measure either around blue or around ultraviolet. This really can't do that properly. So what all those people need, both people working with alt processes and people who want to do things like color process control, is a color densitometer. Now, a color densitometer is actually a much more difficult problem because it has to measure with much more specific spectral conditions. Depending on whether you're doing status M or status A, depending on what kind of material you're measuring, there's very specific wavelengths for red, green, and blue that have to be measured at. You can't just pick arbitrary or you won't match existing legacy densitometers. So I basically have to change completely the way that I'm actually measuring light and even the light source. So, that being said, I've actually started doing the R&D for a color densitometer. Now, I must warn all of you, there's absolutely no guarantee this project will succeed. There are many more technical hurdles to making it happen than there were with the black and white unit. It's not just a matter of whether I can build the device, it's a matter of whether I can get the device to actually give the right readings. Now, to this end, what I've been working on is these little prototypes that use development boards. So this one here takes the base from a Printalyzer Densitometer and a custom top that looks similar and sticks this particular fancy spectral sensor on top so I can get its readings and see how well it works. Another development prototype I've been going with is this one, which is more like a full-up Printalyzer Densitometer shell with a dev board for a different sensor mounted inside of it, and the LED drivers for the transmission light are sort of off on this board on the side just because it's a benchtop experiment. Now, with these sensors, there's a number of problems that need to be solved before I can really move forward. Most notably, are they sensitive enough to pick up the range of densities I need to measure? Some of them are, and some of them aren't. But also, can they give the right results at the right wavelengths or under the right spectral conditions to actually produce numbers that qualify as status A or status M color densitometry? And that's the much harder problem. In fact, in order to fully calibrate these instruments, I'm going to need much fancier equipment than I've been using so far. I might need a full-blown spectrometer in order to get baseline readings to characterize calibration materials. And I may also need to get something called a monochromator in order to calibrate the different wavelength channels of the sensors themselves. At what point I invest in this equipment, I'm not really sure yet. Right now, I'm really at the stage of trying to figure out feasibility. Another big problem is I need good comparison readings. And a lot of older color densitometers that people are using right now, including myself, are old. And one thing I've started to notice in particular is that their blue channels are getting a little wonky. They don't always produce the most stable readings, and I'm not entirely convinced that the linearity of their readings is correct. Now, most calibration materials for these devices are made out of black and white film where none of these problems really manifest. Black and white film responds somewhat evenly across the range, and it really can't stress how accurate the spectral response is for testing. One thing that can, however, is color film, and I do have a number of C41 process control test strips that I've also been measuring as part of these experiments. But I really have no idea at this point if the comparative readings that I'm getting off of my older legacy color densitometers off those strips are actually correct. So getting the right results is a little bit of a challenge right now. It's a problem to work through. Hopefully I can get some help from other people, maybe some labs, and maybe increase the amount of equipment I have to try to see what I can do. So there's no guarantee that the color densitometer project will succeed, and it could very well be a gigantic waste of time that occupies me for months of headbanging frustration, but I'm definitely going to work on it. The other project that I really need to get back to work on at some point, hopefully I'll start working on it again simultaneously, and people keep asking about it a lot, is the product that coined the name Printalyzer, the Printalyzer Enlarging Timer and Exposure Meter. So this is really the project that kicked everything off, and it got a little sidelined in order to develop the densitometer, which was actually originally envisioned as a minimalist accessory for this before it took on a life of its own. So getting this product going again has a number of challenges. There's a number of things that have to be worked through. One of the biggest elephants in the room is the fact that it switches mains power. I'm going to need to work through whatever regulatory red tape I need to deal with for that, or whatever due diligence for liability issues. It's going to be a complicated and annoying issue, and I'm going to need to consult others to figure out how best to address it. Beyond that, there are a couple of other issues that have to be tackled bringing this product forward. One that tends to go down a bit of a rabbit hole when you bring up the conversation is controlling more modern LED type enlargers. This was originally designed to control your standard legacy enlarger that you just control by turning its power on and off. Well, LED enlargers have a bit of a problem in that they're not usually controlled that way and come in two varieties: DIY projects and commercial products. And there's no standards here whatsoever. Commercial products are usually built around their own proprietary timers and might be completely inaccessible to me. DIY projects, on the other hand, are whatever the person building them felt like doing. So if I'm going to be controlling LED enlargers, what I need is a standard interface. And the one idea that keeps coming back to me is this lighting control standard called DMX 512. It is basically a serial protocol based off of RS-485, where you spit out a packet of numbers, either 8-bit values, or you can merge channels together for 16-bit values. That's used to control lighting equipment. Now, the advantage of using something like this, more than anything else, is that it's a standard. Existing off-the-shelf equipment exists for it. Existing relay and dimmer boards exist for it. Adapter cables, physical medium translators, it all exists. So if someone wants to build something using off-the-shelf hardware, they can. Now, there's still nothing that can replicate, I have two outlets, I want to switch with relays, let me do it via DMX. There's no off-the-shelf product for that in that form at a low cost and a compact size. So it's probably not going to replace the electrical outlets on the back of this thing. However, it could be a good way of providing expandability. I just need to figure out where to stick an XLR jack on the back of this device, which is completely out of room, or do something with RJ45. That's something I just need to go and investigate and do some research on. Another thing that has to change with this device is the meter probe used for exposure measurement and enlarger calibration. The light sensor that this was originally built with has been discontinued by the manufacturer, and so I need to select another one. Either another RGB sensor like this uses, or, because I'm not entirely sure that's really beneficial for this application, a more sensitive black and white sensor. I also need to revisit the protocol this cable uses to connect, because in its current form, it doesn't really work well with being hot plugged. And while I don't think hot plug is a common use case, it is unfortunately something that people are going to do. So I need to be able to at least protect against that. But one thing that's still important is this needs to be as simple as possible inside. I've been trying very hard to make sure that this meter probe has no firmware of its own and is controlled entirely by the base unit, which will be really helpful if I ever decide to make more than one of these. Because it's entirely possible the best meter probe for standard black and white photography might not be the same thing for someone who wants to use lights of very different spectral properties. So that's where things stand. If you have any questions or comments, please leave them below in the description. And until later, bye.